On the job, you'll refer to many different types of diagrams associated with the systems in your plant. Although diagrams vary depending on the kinds of systems they represent, there are some aspects of reading them that apply to practically any diagram. A piping and instrumentation diagram, or P&ID as we'll refer to it, represents the piping and process equipment in a system and the instruments that monitor and control conditions in the system. In this part, we'll concentrate on instrument symbols used on P&IDs. Here's an example of a P&ID. These symbols represent the instruments in the system and indicate their locations. A circle containing letters is widely used as the symbol that represents an instrument on a P&ID. The letters designate the type of instrument and its function. The meanings of the letters can be found on an instrument identification chart. Since the meanings of the letters can vary from plant to plant, it's a good idea to check an instrument identification chart when you're reading a P&ID for the first time. The meaning of each letter in the left-hand column varies depending on the position of the letter in the symbol. In most cases, the first letter in the symbol designates the process variable associated with the symbol. For example, A as the first letter indicates that the instrument performs an analysis, such as a pH or density measurement. And L as the first letter means that the instrument measures level. If the first letter doesn't indicate a process variable, its meaning is usually explained on the chart. For example, H as the first letter stands for hand and means that the instrument is operated manually. The second letter in an instrument symbol usually indicates the type of instrument or its function. The second letter in this symbol is an I. So this symbol represents a level indicator. Instruments that are located near a piece of equipment, like the level indicator for this tank, are referred to as local instruments. They're represented by a circle and letters. Remote instruments, which are typically mounted on a panel with other instruments in a control room, are typically identified by a line through the symbol, like the one here. Many instrument symbols contain more than 2 letters. This usually means that the instrument has more than one function. In this case, the third letter, C, means controller. So this is a level indicating controller. In some cases, the third letter is a modifier. For example, according to our identification chart, an L in the third position represents a low value for the process variable. The letters in the symbol stand for level, alarm, low. So this is a low-level alarm. In facilities with many similar control systems, numbers and letters may be added to the symbols to identify separate systems. The symbol identification usually matches the identification of the equipment that the control system is associated with. Reading a P&ID involves identifying and interpreting symbols for instruments and other system equipment. Let's go through an example diagram to see how this is done. As we go through the example, we'll use this instrument identification chart to help us identify and interpret the symbols we find there. This is the diagram we'll be working with. We'll start at acid tank AT1. There is only one instrument symbol shown for the acid tank. The symbol containing the letters LI represents a locally mounted level indicator that shows how much acid there is in the tank. Storage tank ST1 also has a local level indicator. The symbols for equipment and instruments on a P&ID are connected by lines, but the lines aren't all the same. Solid lines typically represent process piping or instrument connections to the process. Lines with slashes usually represent pneumatic signal lines, and dashed lines typically represent electrical signal lines. Let's move on now so we can look at the instruments associated with the mixing tank in this system. There's a symbol containing the letters FI connected to each of the process lines that are connected to the mixing tank. According to the chart, an F as the first letter means flow, and an I as the second letter means an indicating function. So these symbols represent flow indicators. In this case, the flow indicators are mounted locally in the piping leading to the tank. The tank has a local temperature transmitter that sends an electrical signal to a remote temperature indicating recorder, represented by the symbol labeled TIR. It also has a level transmitter, labeled LT. The transmitter is connected by pneumatic tubing to a level indicating controller. The controller sends a pneumatic signal to a control valve. The PI represents a local pressure indicator that shows the discharge pressure of the mixing tank pump. The last group of instruments we'll look at is associated with the dilution tank. This symbol, labeled FRC, represents a local flow recording controller that measures and records flow from the mixing tank and adjusts the flow of water from the water system into the dilution tank. These symbols represent the components in a high-level alarm system. The LT represents a level transmitter that is mounted locally. There are also two other symbols. One contains the letters LSH and the other contains the letters LAH. Referring to our chart, we find that the S as the second letter indicates a switch, and an A as the second letter means an alarm. The H as the third letter signifies a high value for the process variable, in this case, the level of the material in the tank. So the LSH symbol represents a high-level switch, and the symbol containing LAH represents a high-level alarm. There's also a level transmitter connected to a level indicating controller. The controller is connected by pneumatic tubing to an actuator that operates a level control valve. It's called a level control valve because its purpose is to control the level in the dilution tank by regulating flow in the line leaving the tank. In this topic, we looked at an example of a P&ID and the symbols used to represent instruments, and we saw how to read a P&ID. Try some questions now to practice what we've covered. In most cases, the first letter in the symbol designates the process variable associated with the symbol. Solid lines typically represent process piping or instrument connections to the process. Lines with slashes usually represent pneumatic signal lines, and dashed lines typically represent electrical signal lines. System diagrams, or drawings as they're sometimes called, are generally kept in some type of folder or book. There are generally several kinds of drawings for each system, including a legend. A legend, like any other diagram, has a title block that gives important information about the drawing. The title block contains the name of the diagram or drawing and its identification number. The numbers are often listed in the diagram book for reference. The title block also contains the diagram revision number. System diagrams are usually revised when changes are made to the equipment in a system. The revision number indicates which version of the diagram you're looking at. The title block may also include additional information about the diagram or the system it represents. Well, now let's take a look at the kinds of information typically found on a legend. For fluid systems, there is usually a section in the legend for valves and related components. It identifies all of the valve symbols used in the diagrams. In addition to valve symbols, this section shows symbols used for valve actuators. A legend also includes a section that shows symbols for major equipment such as pumps, heat exchangers, tanks, and other equipment. The section of the legend that shows instrument symbols generally includes an instrument identification chart. The chart shows letters used on instrument symbols and what the letters mean. Instrumentation symbols are shown in a section similar to this. The instrumentation section of this legend shows how instruments are shown on system diagrams. There's a separate section on this legend for the different kinds of line symbols. This symbol represents the flow path of material through the system, and these represent instrument signals. Abbreviations used on the diagrams are explained in the abbreviations section. For example, the abbreviation NO next to a valve symbol indicates that the valve is normally open during system operation. The section of the legend labeled System Prefixes explains prefixes that refer to systems at the facility. For example, the pieces of equipment in a lube oil system would have the prefix LO in their identification codes. The last section we'll look at is for miscellaneous symbols. This section contains symbols for components such as strainers and steam traps that do not fit into any of the other categories. System diagrams can be a big help when you're finding your way around a process system for the first time. As an example of how we can use the information on a system diagram, let's follow along on a diagram as we trace the fuel oil system for an oil-fired boiler. This diagram represents the fuel system for the boiler. The fuel oil is stored in tank number 1. We'll begin here and follow the flow path of the oil from the tank to the boiler. Oil leaves the tank through this isolation valve. The first component the oil comes to is shown as 2 circles, each of which contains the letter S. It is the symbol for this duplex strainer. The strainer removes solid particles from the fuel oil. From the strainer, the fuel oil flows to a positive displacement pump. There's a pressure relief valve at the pump discharge. The relief valve routes oil back to the suction side of the pump through this line if the pressure on the discharge side of the pump gets too high. This symbol represents a gate valve that can be used to isolate the pump and the tank from the rest of the system. From there, the oil piping goes to the next major components. 2 heat exchangers that function as heaters for the oil. Each heater has an isolation valve on its inlet side and its outlet side. These valves allow the oil to be routed through either or both heaters as needed. This symbol represents a pneumatically operated globe valve that regulates the flow of steam from the steam system to the oil heaters. According to the diagram, the 2 streams leaving the heaters are combined to form 1 stream to the boiler. In the line to the boiler, there's an isolation valve and a Y strainer. The strainer traps solid particles that could damage valves and other devices downstream. Next in the line are 2 isolation valves and a bypass line around a local flow indicator. This arrangement allows flow to bypass the flow indicator if necessary. The symbol for the valve in the bypass line is filled in to indicate that it is normally closed during system operation. Next is a pressure regulator, which is represented on the diagram by a symbol for a self-regulating valve. Then there is a local temperature indicator and a local pressure indicator. The next group of components includes a pneumatically actuated flow control valve that is connected to a flow controller. The controller and the control valve make up an automatic system that monitors and controls the flow of oil to the boiler. The other valves are for isolating and bypassing the flow controller if necessary. From there, the oil is fed to the boiler. In this topic, we focused on the types of information contained in a diagram legend, and we followed a system diagram as we looked at the components of a plant system. Try some questions now to practice what you've learned. There's a separate section on this legend for the different kinds of line symbols. This symbol represents the flow path of material through the system, and these represent instrument signals. This arrangement allows flow to bypass the flow indicator if necessary. The symbol for the valve in the bypass line is filled in to indicate that it is normally closed during system operation. Electrical diagrams typically include symbols for the major components in electrical systems. These components include transformers, motors, and other components that use electricity, and the protective devices associated with the system. Electrical diagrams also show the connections between the components. This is an example of a one-line diagram for a simple electrical system. One-line diagrams are frequently used to represent electrical systems or individual sections of systems. They use a single line to represent the transmission path for power through the system. We'll look at the components in the main transformer section of this electrical system. This is the symbol for a power transformer. It is the main transformer where power comes into the plant. The transformer converts the incoming high voltage from the distribution lines to a lower voltage that is used within the plant. This symbol represents a current transformer. Current transformers are frequently used to supply current at a reduced value to devices such as ammeters and relays that are used to monitor and control the power in the system. This transformer does not affect the current flowing from the main transformer to the rest of the system, but it does allow the current to be measured. This is the symbol for a circuit breaker. It is closed to energize the system supplied by the main transformer and opened to isolate the system. The symbols shaped like chevrons indicate the circuit breaker can be physically pulled out of the system to isolate the circuit, as you see the technician doing here. There are 6 circuit breakers shown on this diagram. In many cases, electrical components are represented by circles or boxes that contain numbers or letters. For example, a circle labeled A represents an ammeter, a device that measures the flow of electric current. And a box labeled AS represents an ammeter switch. The switch is used to open or close a circuit to the ammeter. These and other abbreviations used on electrical diagrams can be found in a standard diagram abbreviations table. Many electrical devices are identified by number codes rather than letters. The number 51 here indicates that this symbol represents an AC time delay over current relay. The numbers related to electrical components can be found in an American Standard Device Function Numbers table. The electrical system in a plant is designed to carry electric power throughout the plant. The heart of the system is the load center, or main bus. A bus is basically a conductor that connects a power source to several load circuits. Load circuits supply individual loads with power from the load center. A load can be a device such as a motor that uses power, or a device like a transformer or a motor control center that supplies power to other circuits. There are 3 load circuits connected to this load center: a lighting circuit, a motor circuit, and a motor control center. On this diagram, motors are represented by circles containing the letter M. A load center includes devices that monitor and control the power that's being distributed. Voltage is supplied to these devices at a reduced level by a potential transformer. A voltmeter switch labeled VS is closed to allow this voltmeter to measure the voltage of the load center bus. Low voltage can damage electrical equipment, so an undervoltage relay, represented by a circle containing the number 27, is used to open the breaker at the main transformer if the voltage gets too low. Opening the breaker isolates the 480-volt bus and the load circuits connected to it. This diagram also shows a motor circuit that is connected directly to the load center. It is equipped with a breaker. This current transformer supplies power to an instantaneous overcurrent relay and a time delay overcurrent relay. They open the breaker in the motor circuit if current flow is too high. This symbol represents a contactor. It is used to start and stop the motor. The motor control center is basically a bus similar to a load center. It supplies power to several load circuits, but a motor control center generally supplies power only to motors. This motor control center includes 2 motor circuits. For each motor, the diagram shows a motor start circuit that includes a potential transformer, a fuse, a motor contactor, and a start-stop switch. The arrows indicate that the contactors are operated by the start-stop switches. The diagram we've been working with represents a rather simple electrical system, but by now you should have a basic idea of the types of symbols used on one-line electrical diagrams. Try some questions now to check your understanding of electrical symbols. A load center includes devices that monitor and control the power that's being distributed. Voltage is supplied to these devices at a reduced level by a potential transformer. The motor control center is basically a bus similar to a load center. It supplies power to several load circuits, but a motor control center generally supplies power only to motors.